All right, y'all, 9.6, we'll be looking at, like I said, solving equations. So first we'll start out by solving exponential. So exponential equations, y'all, come into form where the variable is the exponent, okay? So this is what's making this exponential. So the first thing I do, if possible, so if it's possible, I'm going to rewrite each side of the equation using the same base. So rewrite each side of the equation using the same base. So if I can get each side to match with the base, then I can invoke what we call the base exponent property. And the base exponent property tells us if a to the x equals a to the y. So I got two sides that are equal. They got the same base. Well, if they're both equal and they got the same base, that means that the exponents have to be equal. So then x equals y. Okay, so we get the bases to match. We set the exponents equal to each other. Now, that's only if it's possible to rewrite each side. If it's not possible to rewrite each side, using the same base, so if it's not possible to rewrite each side using the same base, the first thing I'm going to do, because I got to be able to bring these exponents down. I cannot solve for the variable while it's an exponent. So the way I bring it down is I take a log or an ln of both sides. Because remember, what you do to one side of an equation, you do to the other side. So I'm going to take a log or ln. I'll use the ln if it's got the e in the problem, okay? So I'll take a log or ln of both sides. So what that means, if I take the log of one side of an equation, I got to take the log of the other side. All right, after I take that log or ln, I can then use the power rule. So using the power rule, bring the exponents down and rewrite as a product. So bring the exponents down. And rewrite as a product. So that's what we were doing last week when we were rewriting those logs. And if we had an exponent up there, remember, we brought that exponent down to the front. All right, so once I do that, either I did step one or I did step two. After doing one of those two steps, I'm then going to solve for the variable. And then y'all, the last thing on any equation, check your answers if needed. Okay, so not bad. I'm going to try to rewrite them if I can with the same base, because that's the quickest way to get through it. If not, then I will do the logs or the LNs to get my exponents down and then solve, okay? So y'all, let's start these out. So like I said, the first 9 problems are following these rules for the exponential equations. So these equations will say, or these examples will say, solve for x. So number 1, they're giving me 6 to the x equals 36. So my goal, y'all, since this is 6 raised to an exponent, I need to see, is it possible for me to rewrite 36 as a 6 raised to an exponent? You know, that would be true on this one. I could rewrite 36. So I'm going to rewrite 36 as 6 squared.
Okay.
Right? So using a 6, since I know 6 times 6 is 36, I'm going to rewrite it as 6 squared. So I bring down my 6x. That's going to equal 6 squared. So guess what? I was able to rewrite this with the same base on each side. So since my bases match, remember, if your bases match, that means the exponents are equal. So that means that this x equals this exponent of a 2. Now, if I want to check that, I would put the 2 back in for the x and see if this is true or not. Well, y'all, 6 squared is 36, which equals 36. So that would check off as the correct answer.
So that's all we're doing is just putting the exponent in there that is supposed to equal to on that one.
On basically, yep.
Okay.
And that's what you're figuring out when you rewrite it right here. Now, some of them are going to have just a little bit more work to them, but yeah, that's the basic idea on those. Now, watch this second one. 4 to the 5x equals 16. So I'm looking at this 16. Can I rewrite 16 using a 4 as its base? Well, y'all, we actually can on that one, right?
Yeah.
Because we know that 4 times 4 equals 16. So that would be what, 4 squared? So now we bring down this 4 to the 5x. That's going to equal 4 squared. Well, y'all look at this. The bases match. So that means the exponents are going to be equal to each other. So that means 5x has got to equal 2. So what's going to happen on this one? Somehow we got to find a number that we can put in for this x that we can get a 2 out of. We all watch this. To solve that for the x, we're just going to divide both sides by 5. So the 5's cancel, giving you a 1x. And then nothing we can do to that. So that's going to stay a 2 to the 5th, a 2/5. So if you put that 2/5 in for the x, the 5's cancel, and you end up with 4 squared. Well, y'all, 4 squared is 16, which equals 16. So that answer would check. But I'm still trying to make that 5x equal a 2 in the long run, okay?
What you mean, like make the 5x equals 2 in the long run, other than putting 2 over 5?
Because I know that 4 squared equals 16, right?
Yeah.
So this has to equal 2 in the long run. So
Right.
when we wrote this and these exponents became equal, well, right here it's saying 5x had to equal 2, right?
Okay, yeah.
So we had to find the x that we could put in. So look at this. You have a 5 here. We had to find the x that when we put it in here and multiplied would give me a 2 in the long run.
Right.
Well, guess what? That was to do that, we're going to have to multiply it by a fraction.
Got it. Okay. I see what you're doing.
Because now those 5s cancel.
Okay.
And I'm left with 4 squared.
Okay.
But basically the same thing, right? It's just that
Yeah.
if you got a number up there in front of those X's, you're probably going to end up with a fraction on those.
Yeah.
I'm sorry, where did you get the 5 times the 2/5 right there, the last part? That's
Right here.
yes.
I was just plugging in my answer to see what I would get here.
Okay.
Because I was just checking my answer. That way now, since all I had was a 2, 4 squared equals 16 made that true. So yeah, I was just checking to see what would happen here.
All right.
All right, now watch this, and y'all are going to change the game. I got 5 to the X equals 24. So there's nothing I can do to this 24 to make it a 5 raised to an exponent. Because 5 to the first is 5. 5 squared, well, that's 25. So there's nothing I can do to rewrite this one, okay? So since I can't rewrite this one, I'm going to go right here where it says if it's not possible, we're going to take the log of both sides. So you're going to come in and do log 5 to the X equals log of 24. So remember, if I do a log on this side, I definitely got to do a log on the other side of the equals. But now we took a log of both sides. Now it says using the power rule, bring the exponents down. Well, the only exponent I have is the X. So remember, we got to bring the exponents down to the front. And this left side will become X times log of 5. That's going to equal my log of 24. And that's the whole reason we do the log stuff, is that gives me a way to actually bring those exponents down, okay? So now we got X times the log of 5 equals a log of 24. If I want to make this a 1x over here, I need to divide both sides by this log 5. So we'll have our X log 5 divided by log 5. That's going to equal my log 24 divided by my log 5. So look, these log 5s cancel on the left side, leaving us our X. Now here, since we got logs we're having to play with on this one, we're going to have to use the calculator and round this answer 4 decimal places. Now, y'all, when I do it on the calculator, you gotta shut those parentheses on these logs, okay? So let me go to my calculator. Now, we'll say the easiest way to do these is make them look like a fraction. So just hit alpha y equals and enter and get that fraction notation up. So on top, I had a log of 24. So I'm going to hit log, put in my 24, and close my parentheses. Because remember, it always gives you the opening parentheses on the log. And then arrow down and put in a log. I had a 5 down there. And then close parentheses. Now, I want this to round off 4 decimal places. So I'm going to hit enter. So I'm getting around to what? 1.97, 4. And the 6 has a 3 after it. So I'm going to leave that at 4, 6. All right. So if you got logs in those final answers, you will get decimal answers, okay?
So are we supposed to do exactly that? Put that in the calculator like that?
Oh, yeah, because I can't do logs in our head.
Of course, right. Okay.
Exactly.
And you have to go all the way until you have to go 4 numbers behind the decimal point.
Yeah, you got to go 4 decimal places, okay?
Okay.
So look at the 5th place to determine what you're doing to that 4th place, okay?
Miss Eugene, I'm gonna ask you a question because that really threw me off. I guess not this, but why come? What is the one? What like in that decimal? What is the one?
Okay, so the ones is the one
Why does it not count as? Why does it not count?
because
Like
it's not what they would consider a decimal place.
okay,
When they say decimal places, they're looking after the decimal. So really, this is the tenths,
okay, yeah,
hundredths, thousandths, 10,000ths. So we're really rounding to the nearest 10,000th on this
okay,
thing. Okay. And then this side would be what your ones, tens, hundreds,
got it.
thousands, and so
Okay,
on. Okay.
okay.
All righty, y'all. So what was that? Number 3. So we're on number 4 here. So I might have to pull this down a little more for that one. All righty. So remember, working these ones out where you can rewrite them. You really don't have to use the calculator, but boy, if you got these logs left, definitely got to punch them on a calculator. So let's try this one. 3 to the 9x minus 5 equals 81. So can we rewrite 81 using 3 raised to an exponent? Well, y'all, I would definitely think so, because the easiest way to get an 81 is what, a 9 times 9?
Yeah, I
And
think 3 to the 4th.
So 3 to the 4th, because each of them 9s had 2 3s. So I'm going to rewrite 81 as 3 to the 4th. So that means we got 3 to the 9x minus 5 equals 3 to the 4th. Well, now we got the same basis. So that means this 9x minus 5 has to equal what?
No, I was gonna say 9/5, but I don't think the math
Well,
works on that one.
well, just the start of it. This side we had 3 to the 4th to get 81, right?
Mm-hmm.
So if we want these two sides to equal, then that means that 9x minus 5 has to equal 4. Right? If they're both equal, and we got a 4
Oh yeah,
here,
you're right. Yeah, 9
then
minus
this
5.
has to equal 4 for these to still be equal, right?
Uh-huh.
What we need to do now, solve this for the x, so that when I put in my number for the x, multiply by 9, and then subtract 5, this whole thing has to equal 4, okay?
Is it gonna be 1?
Oh my God, look at y'all go. There you go, because I'm going to add 5. I get 9x equals 9. And then we're going to divide by 9, and look at that. X is definitely going to equal a 1. So see, because 9 minus 5 would give me 4 here, right?
Right.
So the way to make that equal 9, that had to be a 1. 1 times 9 was 9. 9 minus 5 gave me 4. 3 to the 4th equals 81.
I'm glad this one finally made sense because I was totally lost.
Yeah, because we're really when you're able to rewrite them, you're getting the exponent. This thing has to equal. Right here, this 5x had to equal 2, right?
Right.
This one definitely made more sense than the last couple, though.
Well, that's probably because it came out to a nice number here, huh?
So, Mr. Eugene, tell me how you were gonna get 81, how you were gonna guess 81 without plugging in numbers in your calculator. Because I'm not gonna lie, that's what I did, but I'm gonna do it without.
I knew that 9 times 9 was 81.
Mm-hmm.
And I knew that each of them 9s was 3 times 3.
9 times 9, 81. You knew that each 9 was times 3.
So each 9 was 3 times 3 gave me 9. 3
Okay.
times 3 gave me the other 9. And then when you did 9 times 9, you got 81.
Okay.
Mm-hmm.
Oh, okay.
Or y'all heard of them factor tree things, where you start with 81 and you make that a 9 and a 9. But then the 9s I could break down to 3 and 3.
Because that's what I was thinking. It feels like factoring. Like a
Yeah, I'm
different
still
formula.
factoring it out just to see.
Yeah.
Just to see how many. Now I've done this one enough. I know that by now, but no. That's what I'd have done in the beginning. Okay, how many times can I do a 3 to get an 81, if possible? Okay.
Mm-hmm.
So here, 3 to the x equals 5. So we can't rewrite this 5 using a 3, can we? Because 3 to the first is 3. 3 squared is 9. So you cannot take a 3 and turn it into a 5. So remember, since I can't rewrite them using the same base, I'm going to take a log of both sides. So I'll have a log of 3 to the x equals log of 5. Now, we'll say this. I know this exponent has to be in between a 1 and a 2 when I'm done. Because 3 to the first is 3. 3 squared is 9. Well, that 5's in between 3 and 9, which means that exponent's got to be in between a 1 and a 2. So let's see what kind of answer we get when we finish this one. So y'all, we did that so we can bring our x down to the front, because I can't solve it while it's an exponent. So I got to bring the x down. So I get x times my log 3 equals log 5. Now, to make that a 1x, we're going to divide both sides by the log 3. So once again, those logs cancel, making that a 1x. And then once again, I would punch this on the calculator. And y'all, this one will give you an answer of 1.4650. And guess what? That answer is definitely in between 1 and 2. Okay? So if you realize you're just looking for exponents, then these answers sort of make more sense. Now, when I punch this in, is it exactly going to equal 5? Probably not, but it'll be close. But the more digits I would have rounded this out, the closer it would have got to that 5, okay?
Mm-hmm.
So remember, this is what you would call an approximated answer.
Right. The one you said that it'll put the I in there. Is that the one you was talking about when you said it'll put the I? If we
Oh,
set the
well, you
log-
don't have to on these because they're not imaginary.
Okay, yeah, imaginary. Yeah, okay.
All right, y'all, so moving on.
Mr. Eugene, can you go back to that paper real quick? I'm
Uh-huh.
at the very bottom of that last
Okay.
problem we just did.
Okay. And I'll tell you, we got one of the trickier ones is coming up. This number 6 here.
I'm sorry, I do have a question. So do you round up on that fourth decimal? All the way up?
Well, if you punch that one in, let me punch that in real quick. What was
Like
that?
it comes in 1.4649.
Uh-huh. And you
It's
had
not gonna matter on Math Lab if we round up or not.
what was after that last 9?
It was a 7.
Yeah, so that rounded the 9 to a 0. And since the 9 got rounded to a 0, that what was in front of it was a 4 had to turn into a 5. So that 49 basically rounded up to a 50.
Right. Is that going to matter on Math Lab where we round up or not?
Oh, you got to round up. If that
Right.
if that 5th digit is higher than a 4, you got to round it up, okay?
All right.
Oh, okay. So we was on what, number 6, I said. Okay. All right, y'all. This one's trickier. It's going to pull out a lot of different math skills for us. And I always get the same answer on this one. So here we go. 10 to the negative x equals 8 to the 5x. So I'm not going to try to rewrite these using the same base, because there's not a base that I can raise to an exponent to get me a 10 and an 8. Now, y'all, let me recall y'all on one thing. There's only one exponent that I could put into both of these numbers that would give me the same answer on both sides.
Please don't say 1. I'm so
Oh, it won't be 1 because this will give me a 1, 10 to the
Okay.
first. And this will be 8 to the fifth. Woo, those ain't gonna be no.
So are we okay? We looking at the leading coefficients, right? You saying one of
Mhm.
those are going to be
Yeah. So
Okay.
watch this. Watch what I get for my answer though. So I can't rewrite this. So guess what? We're gonna take logs of both sides.
okay.
All right. So now I did that so I can bring these exponents down to the front on both sides. So I get a negative x times log 10 equals that 5x times log 8. So all we did was doing the logs so we could bring those exponents down. So now we got x's on both sides. We need to get these x's on the same side so we can start solving this. So the next step, I'm going to move one of these. And since this one is negative, I'm just going to add a positive x log 10 to both sides. Okay, so because y'all, you got to get these x's on the same side. So this side cancels out, giving me a 0. Now, these are not like terms, so I'm going to have 5x log 8 plus a x log 10. So y'all, here's where the first recall step is. How can I get these two x's to be just one x? Well,
Combine like terms?
sort of close, but I can't combine them because my logs don't match.
Are we going to look for a number that equals 8 and 10?
Oh, and you don't even want to factor it that way.
Oh, okay.
But the factoring I'm going to do to this is a type of factoring. Think about this. I'm going to factor out the GCF.
Okay.
So think about that. What's the greatest common factor these two things have in common?
8 and 10.
2?
Oh, well, they both don't have a 2 in them. Well, don't worry about these logs because remember.
Oh. The
what else do they have in
the
common?
X's. Okay.
The X's.
Oh, the X's. I'm sure looking at the numbers. Okay.
Yeah, remember they got X's. And the only way I can turn these two X's into one X is to factor them out as a GCF because nothing else is like terms. So if you factor out the X, you get a 5 log 8 in the parentheses. Plus, you factor out this X, you get a log 10. So if you notice, all I did was pulled out that X.
Mm-hmm.
But now I got one X, which I can now solve for. And to solve this for the X, I'm going to divide both sides by 5 log 8 plus log 0. So over here, I'll get 0 divided. Because remember, this is being multiplied here. So now we divide by this factor, 5 log 8 plus log 10. That's going to equal the right side divided by that. So look here, this stuff cancels now, don't it? So that cancels. Now look, all that's left is the X. Now think about this. What is 0 divided by all this equal?
0?
Okay, 0. 0 divided by anything will be a 0.
Mm-hmm.
And y'all, that goes back to what I said earlier. The only exponent I can put behind that 10 and that 8 that would make them equal is a 0. What's 10 to the 0 equal? 1. What's 8 to the 0 equal?
1.
1.
Oh, you told us that. You said anything to the 0 equal 1.
Anything to the 0 equals 1. So that makes this 1 equal that 1. So that 0 checks out and we get to move on. I'll get y'all remembering about that zero exponent by the end of the year, right? All right, watch this. E to the T equals 153. Now, guess what? I'm not even attempting to try to rewrite 153 using the E. That's probably impossible. So I need to solve this for that T. Now, since I got an E here, I'm not going to take logs of both sides. I'm going to take an ln of both sides. I'm going to do the ln of E to the T. That's going to equal the ln of 153. Now, y'all, I'll tell you the truth. Why did I choose ln on this one? Because remember, ln of E is really a log base E of E. Remember, ln is really a log base E. So if you got a log base E of E, what does that equal in the long run? Anytime the base matches that result, that equals 1. So watch this. You bring that T down using the power rule. Well, y'all, that's T brought down, but what's ln of 1 equal? Ln of 1 equals 1. And T times 1 is just going to give you the T. So when you got E raised to an exponent, and you take an ln of that, in the long run, it equals the exponent. Now, the right side, I can't do nothing with that, so I'm going to bring down that ln of 153. So that now T, estimating that to 4 decimal places, I get a 5.0304. Okay, so when you got E, we use the ln. So I'll have another one doing the ln, the E, okay? So notice toward the end, they're not giving us many that we can rewrite. We're having to go through and do this ln and log stuff to them. So 8 has the E again, to the negative 0.87t. That's going to equal 0.89. All right, so I'm not going to try to rewrite this one because that's probably impossible. So I need to bring the exponent down. So since that's the E, we're going to take an ln of both sides. ln of E to the negative 0.87t will equal the ln of the 0.89. See, because what this calculator does, remember, these ln's and logs, they're finding exponents. So they're finding what this t has to equal, that it can be multiplied by that negative 0.87, and then e to that to get me somewhere really close to that number. All right, y'all, so let's see what we're going to get here. We're going to bring the exponent down. But remember, that's the ln of e raised to an exponent. So the ln of e will give me a 1. So this left side is going to be negative 0.87t. That's going to equal my ln 0.89. So y'all look at that. I got one more step because I need that to be a 1t. So we need to divide both sides by that negative 0.87. And that'll equal the ln of our 0.89 divided by negative 0.87. So y'all look, this cancels, giving me a 1t over here. And this, I would punch in my calculator, and let's see, this is going to give me a 0.13 3, 9. So, like I said, you just got to watch it on these ones where you got the LNs and the logs left, because those are going to definitely give you 4 decimal places, okay? All right, y'all. So one more
Mr. Rathon,
exponential.
how do you put that how do you put the LN in the calculator?
In my
Oh, never mind.
right
Never
on the
mind.
front there, remember?
It's
Next to the 4 or the 7, I can't remember, but one of them two.
right on
Yeah,
the
it's
log.
next to the 4.
Okay.
The log. Just remember log and LN together.
There you go.
Yeah. Okay.
All right, now this one's another tricky one. This last one for the exponential, and then we will turn into logs after this one. So I got 6 to the x equals 3 to the x plus 1. So I can't rewrite this one, so I'm going to take my logs of both sides. So y'all, log 6 to the x equals log of 3 to the x plus 1. All right, so we did that so we could bring these exponents down. And I got exponents on both sides here. So this one will give me an x times log 6. Now, I got 2 terms in this exponent. So when I bring it down, I'm going to put it in parentheses, because the x plus 1 both have to be multiplied by this log 3 down here. Okay, anytime you got more than one term in the exponent, every part gets multiplied by the log 3. So this side I'm going to leave the same for the second. But this side, we're going to multiply the x and the 1 by the log 3. So it's sort of like you're doing distributive property in reverse. So you get an x times log 3 is an x log 3. And then 1 times log 3 is plus a 1 log 3. So treat it like there's a 1 in front of that, since I don't have nothing in front of my log. So now we're looking at this. I got an x here, and I got an x here. I need to get all my x's on one side. So to move this x log 3 to this side, you got to subtract x log 3 from both sides. So y'all, let's keep up with what we got. These are not like terms. So I'm going to have an x log 6 minus an x log 3 equal to, over here, all that's going to be left is the log 3. All right, so I took the log to bring the exponents down. I distributed this one because it had 2 terms. At this point, I had to get all my x's on one side, so we subtracted this x from both sides. So here's the question of the day. I got an x here, and I got an x here. How can you turn these 2 x's into 1 x? And remember, they're not like terms, so you can't add these or subtract them. There's only one thing I can do.
Hold on.
How come you can't subtract the log x log 3 from the x log 6? Aren't they like similar enough?
Well, they're not like terms, because this log 6 would give me some number. This log 3.
Well, okay, they're
Since
different.
they're different numbers, yeah.
Are you gonna factor out the
After
x's?
GCF,
I'm gonna factor out the GCF. There you go.
we both was thinking the same thing.
I heard that. Factor out that GCF. That's the only way you can get these x's to be 1 when you got unlike terms, okay?
So it would be x parentheses log 6 minus log 3 equals log, or close parentheses equals log 3.
Equals log 3. And you remember up here when I had the x and I had all this log stuff? Well, I got an x with all this log stuff. So that means I need to divide both sides by all that log stuff, right?
Right.
So this means we'll have our x log 6 minus log 3 divided by log 6 minus log 3. That'll equal this log 3 divided by log 6 minus log 3. Well, this side, those cancel, and you do got your x. Now on this one, I would probably use the y equals on my calculator for sure and make this look like a fraction. So y'all let me show you how I would do that one on my calculator.
Renee, go in here and eat.
So let me clear all this other stuff off.
Yes.
So I would hit alpha y equals to make that a fraction.
No, eat.
And then I would have log 3 on top. So log 3, close parentheses, and then arrow down, and I would do my log 6, close parentheses, minus my log 3, close parentheses. Make it look just like it on that paper. Hit enter, and I get what, a 1.58. So there's another one with a 49, but it's got a 6 after it.
So it's gonna be is it gonna be 50?
It's gonna be 50. There you go. So 1.5850. So it's like when that last number is a 9 and it rounds up, you're really almost rounding 2 decimal places off.
Right. Because
Okay.
you got that 9 and that 6.
There you go. All righty. So that was our exponential equations. So now we're going to get into logarithmic. So these will be the steps to solving logarithmic equations.
Is this still 9.6?
Uh-huh.
Okay.
But these last 8 we're doing log equations instead of the exponential. So the log ones, remember, log equations are like y equals log
Right.
a of x. They're sort of similar, but they're different. So now here's the first thing I look at on these. If needed, combine logs on each side. Now, I'm not talking if I got a log on one side and a log on the other. I'm talking about if I got more than 2 logs on one side, I'm going to combine them, and I'm going to write it as a single log on each side. All right, so I start out seeing if I can add any logs on either side. Then I look at it and I say, do we have a log base equal to a log base? This only works if you got a log on each side of the equals. But if I do have a log on each side of the equals, I can invoke logarithmic equality. Sort of like the one I had with the exponents and the bases matched. We said the exponents were equal. Well, y'all, if the logs match, so if I got a log base A of m equal to a log base A of n, then, so if the bases are the same and you got 2 sides that are equal, that means this m has to equal that n. Okay, so if I got a log on each side, that's what I'm going to do. I'm going to write it as the result equals the result. Now, If not, so if I don't have a log base equal to a log base, my next step to try, I'm going to rewrite it as exponential. So then rewrite as exponential. So this was the stuff we did in 9.3 when they gave me the log blah blah and I had to write it as the base to an exponent equaled. That's doing this stuff. At that point, solve for the variable. And then what's really important on log equations, check the answer if needed. So let me ask y'all this. Do y'all remember we had some problems in 9.3, 9.4? Can I take the log of a negative number? Well, hell, y'all, let's try that. And let's see. Let's go to our calculator here a second. So do y'all remember when I pulled up log and I did something like a negative 36?
You can't take the log of it.
Yeah, because you punch enter and remember it tells you, oh, that's not a real number. That'd be more like an imaginary answer, okay? So just remember, check those because we cannot take logs of negative numbers. So on these problems, when you get one positive answer and one negative answer, when you factor this stuff and get both answers, remember, throw away those negative answers. We cannot keep them, okay? We only going to keep our positive answers. Oh, you also guess what? Solve for X. So these start at number 10, like I said. So the first one is a log base 4 of X equals 2. So guess what? I don't have more than 2 logs over here, so I cannot combine them. I don't have a log base equal to a log base because this side don't have a log base. So I'm down here, it says rewrite as exponential. So this one, I'm going to rewrite. So remember, the 4 is your base. The 2 is your exponent. And that's going to equal your result, which is the X. So y'all, that X is by itself. So all I got to know is, what is 4 squared?
Is that 8?
Oh, we're going to.
Oh, 16.
16.
Kick someone out of my class, y'all.
My bad. That's 16.
There you go. All righty, here we go. Log of X equals -5. So only got one log here, so I can't combine. Don't have a log on both sides, so I'm going to have to rewrite this one. But y'all, here's the thing. This one ain't got a base right here. What is that base did we say if there wasn't a number here?
10?
Oh my God, look at that, 10. The exponent is -5, and that's going to equal our X. So now this one, they want it in decimal form. So what you do to put this in decimal form, you write 1. And that -5 means I need to move my decimal left 5 spots. So I would go 1, 2, 3, 4, 5. So that means I had to add a 0, 0, 0, and a 0. So that this would give me 0.00001. So if you got a -6, you're going to move you're going to have 5 zeros instead of 4, okay? And that's how you turn these 10 to the negative fifths into just a number. Okay. Alrighty, so that was a tricky one because you had to play with the decimals. And MATLAB won't take it as a 10 to the fifth, and it wants it more as the decimal, okay? All right, y'all, here we go. Log base 6 of 4x minus 4 equals 4. So notice, only got the single log, so I cannot do nothing except down here where I rewrite it. So I'll tell you this, they start out doing a lot of rewriting, and then they add steps as you go. So the base is 6. Exponent is a 4. And 6 to the 4th has to equal 4x minus 4. So the base, exponent, result. All right, y'all, so 6 to the 4th, I would probably figure out what that equaled first. And that's going to give me like 1296. That's going to equal 4x minus 4. So 2 more steps to have this one solved. First, we're going to add 4 to both sides. So y'all look at that. 1300 will equal 4x. And now we're going to turn that into a 1x. So divide both sides by the 4. So notice my 4's cancel, giving me my 1x. Ooh, all right, y'all. What's this 1300 divided by 4 giving me? Oh, what's that? 300 and what did you just say?
325, 325.
325. So basically, I'll tell you what. On these ones, this stuff that we're solving for inside in here, it equals whatever 6 to the 4th is going to say. That's what this 1296 is. It's what this part equals. So we just basically solving for what times this minus 4 would give me that 1296. So similar to the exponential, but ooh, they still different, okay? All right, so watch this one. We're going to start up into steps on it. This one has a log x plus a log x minus 21. All this equals 2. Whoops, that's 2 different problems. So let me write this one off here. So guess what? If needed, combine logs. Well, I got 2 logs over here on the left side. So we need to write these as a single log. So this comes from our last lesson last Wednesday. If I got 2 logs that are being added, would I rewrite them as a product or would I rewrite them as a quotient? Well, y'all, since they're being added, we would rewrite this side as a product. So bring out your log, and then we'll have the x times x minus 21, all equal to R2. So added, we write them as a product. If they were being subtracted, then I would write them as a quotient, okay? Now, I'm going to go one step further, and I'm going to get rid of these parentheses by distributing that x. So we got an x times x, which is going to give y'all x squared. And then you got x times negative 21, which gives you negative 21x. All this equal to 2. So now, we're going to now rewrite this as exponential. Because I still don't have a log base on each side yet. I only got the single log here, okay? So if I'm going to rewrite it as exponential, tell me this. There's not a base here. So what y'all tell me that number was when there's not a base by that log?
Is it 10 again?
It's going to be 10 again. So 10 exponent of 2. So 10 squared is going to equal that x squared minus 21x. All righty, y'all. What does 10 squared equal? And if y'all say 20, you're out.
100.
And 100?
I think you're fixed on those, huh? So my 100 equals my x squared minus 21x. So now what we got going on? We got an x squared in here. So this is going to be a quadratic equation. So I need to get a 0 on this side and move that 100 over here. So we're going to subtract that 100. So remember, once you start getting these quadratic ones, the x squareds and the x terms, you want to get everything on one side equal to 0. So I get 0 will now equal to x squared minus 21x minus 100. All right, y'all. So now it's time to factor. I got an x.
God, what is this?
X squared is x into x. Remember, the last number is negative, so you're going to have unlike signs. So check this out. Give me some factors of 100 that'll subtract and give me a 21. So not 10 by 10, right? 10 times 10, those give me a 0 when I subtract them. So y'all, what else will give me 100 when you multiply?
And you said
Is it 4 and 25?
Yeah, that's what I was gonna say. 4 and 25.
Yeah, 4 times 25. That gives you 21 if you was to subtract them numbers. So remember, the bigger number is negative, like the middle number. So 25 is negative, 4 will be positive. All right, to continue that, I'm going to set both these equal to 0 and solve for those x's. So y'all, the first one, we're going to subtract 4, and I get x is a negative 4. The second one, I'm going to add 25, and I get x equals a positive 25. So what would y'all put as my final answer?
Is it negative 4 and 25?
Oh, y'all, what'd we say right here on this? Check if needed, because
25.
Oh, it's gonna be 25.
yeah, because we cannot. So on this one, you gotta cancel out that negative answer, y'all.
Okay.
And the only answer is the
25.
25, okay? So yeah, most of these where I had to factor, we get one positive and one negative answer usually. So be careful on that, okay?
So always take the positive number.
Always take the positive number. Because if you're trying to check it and you put a log of negative 4 here, guess what? Error message right off the bat. Okay. You'll get one of those, what's it say? Not real answers, blah, blah, blah.
Real number.
Yeah. All right, 14. Log base 3 of t plus 16 minus a log 3 of t plus 7 is going to equal a log base 3 of t. So y'all, I ain't gonna lie, to bringing it all on us, but guess what? This left side has 2 logs, so we need to rewrite as a single log. But look at this. This one's being subtracted. So remember, if they're being subtracted, we got to rewrite it as a quotient. So bring out your log 3. Remember, the positive factor was always on top. So my t plus 16 will go on top. And then the factor being subtracted, the t plus 7 goes to the bottom. All of this will equal a log base 3 of a t. Oh, y'all, look at this. Don't these log bases match on each side? I got a log base 3 here, equal to a log base 3 on this side. So remember, if the log bases match each side, then we know that this t plus 16 over t plus 7 has to equal our t from the right side. Okay, now I'm going to make this t look like a fraction by adding a 1 under it. Now this is a fraction equal to a fraction. So to solve this, I'm going to cross multiply. I'm going to take this top times 1. So I get 1 times t plus 16. That's going to equal that bottom times that top. So that'll be a t times t plus 7. Okay? So when you got a fraction equal to a fraction, cross multiply. Now, y'all, I'm going to get rid of parentheses, but this side, 1 times t plus 16 is just going to be t plus 16. So I distributed my 1, basically. Now here, let's distribute that t. So t times t.
T squared.
And then t times 7.
7t.
7t. Oh, so look at this. We got a t squared term again and some t terms. So we need all this stuff on one side so that we can get a 0 over here. So y'all, what you're going to do to move both of these, you're going to subtract t from both sides, and you're going to subtract 16 from both sides. So got to move both of these over here, because this side, we got to get that 0. All right, bring down my t squared. All right, here, 7t minus 1t leaves me a 6t. And then here, bring down that negative 16. So guess what time it is? We get to factor again. So the t squared is a t and a t. And y'all, ain't going to lie, all these are going to be negative at the end because you're going to get 1 positive and 1 negative every time, okay?
Okay, hold on, Miss.
T plus
Miss-
8t minus 2.
Where did you get? I'm sorry. Where did you get the 6t?
Oh, 7t minus 1t.
Got it. Okay, 17.
Okay.
Okay. Proceed.
All right, y'all. So I need factors of 16 that if I subtract them gave me a 6.
T plus 8t minus 2.
Okay, so what'd y'all just say? Plus 8, you said?
Yes, and minus 2.
And minus 2. There you go. All right, because those add up to get me a 6. Good job. Now, set both them equal to 0. And y'all look at that. I'm going to get a minus 8 on the first one. And a plus 2 on the second one. So your final answer?
2.
2.
There you go.
Yeah.
Scratch out that negative 8, y'all. And the only answer is our 2 on that one, okay? All righty. This one will be similar but different. So watch this one. I got a log base 4 of x plus 1 minus a log base 4 of x. All that's going to equal 3. They're similar, except notice this right side don't have a log on it this time. But we have 2 logs on the left side. So once again, we're going to write that as a single log. And think about it, they're being subtracted. So over here, when they were being subtracted, we wrote it as a quotient. So right here, we're going to write this as a quotient. We're going to break out our log 4. So this positive factor, the x plus 1 goes to the top. The factor being subtracted, that x goes to the bottom. And all that's going to equal 3. So what happens on this one? See, over here I had the 2 logs, so I could set everything equal. Over here, we just got 1 log equal to a number. So this one, we're going to rewrite as exponential. Well, this time we got a base. Our base is 4. Our exponent is 3. And 4 to the third has to equal the x plus 1 over x. So y'all, what I would start out by is figuring out what that 4 to the third power equals. So 4 times 4 times 4.
64.
Okay, so I got 64 equals x plus 1 over x. So what are we going to treat the 64 like it's got a 100 so that we can cross multiply this, okay? So take this 64 times that x, and you get 64x. That's going to equal this 1 times that x plus 1 there. Well, what 1 times x plus 1, that's basically just going to be x plus 1, okay? So, y'all, I need to get this x on this side. So let's subtract the x from both sides. So let's see what I get. 64 minus 1, that's going to give me 63x equal to that 1. So I need my last step that I can do to make this 63x's into a 1x. I'm going to divide both sides by 63. So y'all look, those 63s cancel. You got your x. And y'all, I can't do nothing with that, so I'm going to leave that a 1 over 63. So when y'all do 15, you're going to get a 1 over something here. The only thing I've seen them change on this are the 4s and the 3. But everything else, you'll probably get the x plus 1 and the x just like I did and everything else, okay? All right, so they get a little trickier when you got to do all that combining to them. So let's knock out these last two, 16 and 17. So y'all watch this one, 16 log base 3 of x plus log base 3 x minus 1 is going to equal a log base 3 of a 6. Now, I sort of like these when they got logs on both sides. The tricky part is this part. We got to write it as a single log.
Is it because they like terms will make it hard?
Because that log 3 and that log 3, definitely. As long as that part's like, then you got to rewrite these because we got more than one log over here. Mm-hmm. And since these are being added, we're going to write it as a product. So we bring out the log 3, and we will take this x times that x minus 1. That's going to equal log 3 of a 6. So that's the big thing you got to realize on this one. Being added, I write them as a product here. Now, let's figure out what that equals. So log base 3. So y'all, what's that going to give me? X times x minus 1. Distribute that x and see what you get. So how about the x times x?
X squared.
And then the x times -1 is just our negative x. That's going to equal log base 3 of a 6. But look at this. I now have a log base equal to a log base. Both sides have a log base 3. That means that this x squared minus x has to equal that 6. Uh-oh, y'all. Quadratic again. So where the 6 is, you need a 0.
So you need to subtract x or subtract 6. Okay.
Subtract that 6, yeah. Because that x is already over here, so we just want to move that number over. So x squared minus x minus 6 equals 0. Because what's really vital is that you get a 0 on one side or the other, okay? So guess what? You now get to factor that. Now remember, it'll be an x and an x. The last one's always going to be negative on these problems. So you get a positive and a negative. What factors of 6 will subtract to give me a 1? So 6 can be 1 times 6, but that subtracts to give me a 5. So what else will multiply to give me a 6?
2 and 3.
2 and 3. So the 3 will be negative like the middle, and the 2 positive. All right, y'all, so set both these equal to 0. Subtract 2 on your first one. And then add 3 on the second one. So my final answer is going to be x equals a positive 3. So any of these where you're factoring, every single one we've done has had unlike signs, okay? That way you can only get one of these two numbers to be your answers. All right, y'all. So the last one of these.
Oh, Mr. Eugene, tell me this. Based on whether the log equals product, quotient, that determines how we do the whole problem.
Exactly. And I'm figuring out by is it being added or is it being subtracted.
Okay.
Okay. All right, y'all. Log 3 of x plus 12 plus log 3 x minus 12, all that equals a 4. So look, this one's being added just like this one was being added. So I'm going to rewrite these as a product. There you go. So bring out that log 3. So that'll give me what? X plus 12 times the x minus 12. And all of that's going to equal R4. So, whoops, I didn't put that there, but we did what? Right as a single log. All righty. And let's multiply this out before we do anything else. Y'all, this is perfect. These are conjugate pairs. So this will factor into perfect squares, which means we're shortcutting it because those middle terms and outers are always going to cancel. So the shortcut would be to x times x, which is x squared. And then the 12 times negative 12 is a negative 144. All equal to a 4. So remember, perfect squares, when you got these conjugate pairs. In conjugate pairs, you multiply the first two together, then the last two, okay? All right, so now we don't have a log over here, so this one we have to rewrite as exponential. So the base they give me is a 3. The exponent is a 4. And that has to equal the x squared minus 144. So y'all, we got to figure out what 3 to the 4th power is. So hit that on a calculator and see what you get.
81.
Okay, so I got 81 equals x squared minus 144. Now I'm going to solve this one different than over here. Because over here I had an x term. Over here I just got the x squareds and a bunch of numbers. So the easiest way to do it when you don't have that x term in the middle is to take square roots. So to take square roots on this one, I'm going to add 144 to both sides. So y'all, let's see, 81 plus 144 gives me 225 equal to my x squared. So now we're going to take a square root. And remember, square roots come up as positive or negative. So y'all, this will give me a positive or negative. What is the square root of 225?
$15.
So 15. So we get a plus or minus 15 equal to our x. So that means x equals 15, x equals negative 15. But my final answer is
Positive 15.
positive 15. So kick out that negative 15. So y'all, that is 9.6. It's a little tricky because some of the equations are long, but it's just mainly because you're having to do the single logs and do all this rewriting, okay? 9.7 come Wednesday night. I doubt we'll be here longer than 30 minutes on Wednesday night, okay? 9.7 is pretty short compared to this one.
Okay. Did we say so? So it's okay. Next week is gonna go the same as usual, right?
So here's my plan. So the 9.6 homework, I'll say this, it was just doing the homework for 9.6. Let me find one of my problems real quick. The 9.6 homework is just doing this cross multiplying stuff. But we seen how I was doing it here. And then it had you practice a little factoring. Because remember, on some of these, I had to factor at the end. So it's got 3 where you cross multiply and 2 where you factor. So if you don't get those, I'll knock them out Wednesday before we do the 9-7.
Okay.
So here's my plans. So next week, hopefully you're going to just take it off next week and eat turkey. But when we come back, so let's see, when we come back, it'll be the 27th. So the Monday we come back, the 27th, I'm going to review test 4.
Okay.
Now I got the study guide and everything ready for it. So if you did want to play with the test 4 review during Thanksgiving, you can play with that and practice it and do whatever. So that'll be that Monday. Wednesday, I guess will be the 29th. I'm going to start final exam reviewing.
Okay.
That next
Mr.
Monday.
Oh, never mind. Go ahead.
And then Monday, that'll be like 12. Oh, Lord, the 4th. Let me look on this calendar real quick. So where am I at? 27, 29. So Monday will be the 4th. On that day, I'll review for the final exam again.
Okay.
This will be our last class. Online will be 12/4. On 12/6, that Wednesday, final is going to open. So the final will open on 12/6. and it's going to be due Sunday, 12/10. So 6, 9, 10. So you basically got 5 days there to work that final.
Do we still have time to make up any of the past homework assignments?
All that homework it'll allow you to do those assignments.
Okay.
So especially next week, y'all, you got all week. If there's any of them homeworks you got to make up and stuff, that'd be
Yeah, I planned on it next week.
Yeah, me too. For
yeah,
sure.
that'll be the time to do that. So, and then if you notice, we're still light after the break. All we're doing is reviewing. So really, you got that next week, almost 2 more weeks after that. Everything will shut down on that date, though, at midnight on 12/10.
Okay, cool. Okay.
All math labs going to shut down. So if you got anything that's got to be made up, y'all, like I said, we just got 3 or 4 weeks left of this class. Okay.
Okay.
So y'all, Wednesday night, like I said, will be our last lecture over new material. After that, everything's review.
Okay.
So I always like these log equations and stuff. They were sort of fun once you figure them out. So y'all play with that. I'm going to stop my share and cut my video off.
You said Monday